Okay, so flipping the paper over, 14, we have two problems for 14. We need to state the piecewise function of this thing, okay? So a piecewise function is really a function composed of different pieces. So we have one piece right here. What is this? Is this a parabola? No, it's a line, right? And if you were to extend the line, let me just do this, extend it, right? Would you be able to give me an m value and a b value of that extended line? What would the m value be? What's the slope of that line?
1.
Up 1 over 1, which is just 1. Okay, that's great. How about the b value of that line that I extended? Where does it cross the y-axis? 2. So you have an m, you have a b. You'll be able to write the equation of this guy. It's y equals 1x plus 2, or y equals x plus 2. Now, y equals x plus 2 is the full entire line, right? Now, we don't have the full entire line. It actually, you could think of it from here to the left. That's the only piece of the line. So I don't want this whole equation. I only want the piece of the equation. So how are we going to do that? We're going to first start by starting our function form piece, not our pink. Okay. We're going to start by writing f of x, and then we're going to start by writing this part of our function, the x plus 2 part. Now we need to give it a restriction. Now the restriction is this line does not exist at negative 0.5 or at 0 on x. It doesn't exist on any of the positive x values. It starts right here at x equals negative 1, and it's less than negative 1. Does that make sense? So my restriction on that first piece is x has to be less than or equal to negative 1. Does that make sense? And you should have an if right here. So x plus 2 if x is less than or equal to negative 1. That's a restriction. Now let's move on to the next piece. This next piece, imagine that you had this line, just a straight line going right through here. What would that line be? What would the equation of that line be? That would be y equals 1. Let me do it in blue here. Y equals 1. If you were to think about this never-ending line, right? However, you don't want to think about the never-ending line. You only want to think of the restriction from here to here. So let's first write down this function inside my piecewise function. Now remember, this is y equals x plus 2. There it is, y equals x plus 2. Over here, y equals 1. Y equals, what am I going to put right here? 1. So let's put a 1 right there. Now, what about the restrictions? You're going to say if, and you're going to need a compound inequality. You're going to need a compound inequality that shows you from here to here. So that would be from negative 1 to positive 1. So I'm going to put if negative 1, positive 1, with the x in the middle, with less than symbols, and they're or equal to because they're solid dots. And now for the last part of this line, in order to really understand it, well, first of all, it looks a little crooked. I apologize. We do have a point right here, and we do have a point right here. So this should look like a straight line, okay? That straight line, if you continue with the pattern, it's going to go down 1, 2, 3 over, so it would cross right here at the y value or y-intercept of negative 2. So what would this green line, what would the equation be? It would be y equals, what's the slope? 3, or 3 over 1x. I'll just put 3x. And then what's the b value? Minus 2. So that's my green line, but I don't want the entire line. I don't want the entire line. I only want the piece of it that's from x equals 1 and greater. All right? So let me first write down the machine itself, the function part of it itself, the 3x minus 2. Okay. But now we have to work on our restriction, right? This equation, you only want to see the right side of this green line. In other words, you only want to see the x values that are what? You want to see x values that are less than 1 or greater than or equal to 1? Greater than or equal to. So you're going to put if x is greater than or equal to 1. Ladies and gentlemen, this is your piecewise function right there with the restrictions. So you're going to have to be able to do that. Now, of course, on your multiple choice, these piecewise functions are going to be given to you. So technically, you could look at option A and say, okay, this is y equals x plus 2. How would I graph that? Oh, it crosses at 2. It goes up 1 over 1. So this is it. Oh, yeah, this is this piece of the line. Let me check out the restriction. So you could go through the answers and check it out. But it's always a great idea to be able to know how to come up with this from scratch and then be able to look for your answer on your multiple choice. Moving on to the next one, which I kind of wrote on already. I apologize. So we have, let's look at this piece down here. How am I going to represent that piece? What's that equation? Y equals what? -2. Thank you. Right? Why? Because this guy's a flat line crossing right through the y value of -2. So that equation is y equals -2. How about this line right here? This one, what's the slope of this guy? What's the slope? -1. Because you're going down 1 over 1. Right? Now, if you were to continue going down 1 over 1, down 1 over 1, it would be that line right there. And what's the b value of that line? 4. Okay? So your equation of this line is y equals -x plus 4. Does everybody agree with that? Okay? And let's go for the last equation right here. What's the slope from here to here? Or from here to here? Up 1 over 1. So the m value is 1 also. What's the b value? Where does it cross the y-axis? 0. So we have an equation y equals 1x plus 0. So you're just going to have the equation y equals x. So ladies and gentlemen, we have all three equations. We just need to write it in a piecewise function and with the restrictions. So let's start by writing our answer. F of x equals, and you have this squiggly thing right here. We're going to start from left to right. So this is the equation y equals -2. So you have y equals, I want to put -2 right here. And of course you need to say if what? If x is what? Less than or equal to -3. Perfect. If x less than or equal to, running out of space here, -3. Moving on to the next one, the black line over there. So that black line says y equals -x plus 4. Y equals -x plus 4 belongs right there. So I want to put -x plus 4 right there. Now we need a restriction. The restriction is going to be a compound inequality from here to here, from this x value of -3 to this x value of 0. And notice that these are open dots, so you're not going to put a solid line underneath your inequality. So what would the restriction be? Anybody? From where to where? -3 to 0. And you're going to put an x in the middle. And your inequality symbols will be the less than. I hope you guys understand that. And moving on to the final equation. The final equation is y equals x. Let me change colors here. So you have y equals x. So you have y equals, we're going to put an x right here. And the restriction on this last one is if what? X is greater than or equal to 0. So that's your piecewise function right there. So we're going to solve each system of equations. This is an easy one. It's a 2 by 2. And not only that, you have a variable by itself, so you might want to do, instead of linear combinations, you could always go to linear combinations, but you might want to substitute. It's pretty easy to substitute here. It tells you that y equals x minus 3. So if you take that x minus 3 and put it right inside y, if you replace it, if you substitute it, you're going to end up with x plus, but instead of y, you're going to have the x minus 3. And then you're going to have the equals 5 at the end. Okay? Now notice that the parentheses are unnecessary because there's no number to distribute. So you don't even need the parentheses. You could just jump right into combining like terms. Pretend the parentheses are not even there. So you could add x plus x. That's 2x minus 3 equals 5. Of course, you're going to add 3 to both sides. And you're going to have 2x equals 8, which means x equals 4. So you have one answer. All you got to do is find the other answer by taking this x value of 4 and plugging it in either to this x or to this x. I'm going to go with the top one. Plug in 4 right here and it'll tell you y equals what? If you plug in this 4 right there, y equals what?
4 minus 3.
4 minus 3, so y equals 1. Ladies and gentlemen, you found your answer to 15a. It's the coordinate 4, 1. Or x equals 4, y equals 1.
Can you do the same on all of them?
You could do the same to 15b and c. Wow, that's weird. Because all of them already have y by itself. Now, if you didn't have y by itself, like let's say you had this x on this side over here, let's just pretend that it said negative x plus y. I mean, you could technically move the x over and make it a negative x plus y equals negative 7. And then you'd have the 2x plus y equals 8. Then you could worry about combining and canceling. But you'd have to multiply the bottom equation by negative to be able to get the y's to cancel. So you'd be able to change it. That way the y's cancel. You get negative 3x equals, what's that going to be? Negative 15? And then you could divide both sides by negative 3, and you'll get x equals positive 5. And then you plug it back in to find your other answer. But it's rare, but in this case it's easier to just take that x minus 7 and plug it in right there, and you're going to solve it. You're going to get the same exact answer, x equals 5. So actually, yeah, I wouldn't even go with this method that I did right here. I wouldn't even do linear combinations. So maybe we should just scratch that out. And if you did plug in the x minus 7 in here, you'd have 2x plus x minus 7. Let me just write that. Where could I write that? Over here, somewhere on the side. You'd have 2x plus x minus 7 equals 8. If you plugged it into the bottom equation, that would be 3x minus 7 equals 8. That would be 3x equals 15, which means x equals 5. See, same answer. Substitution works a little bit easier because you already have the variable isolated. Let me jump. Oh yeah, but you still need to finish this off. I'm sorry. You need to take this 5 and plug it in right there into the x. So if your x is 5, y is going to equal 5 take away 7. So if you have y equal 5 take away 7, that's going to be y equals negative 2. So that's your answer for 15b. X equals 5, y equals negative 2. You guys could try 15c on your own. And we're just going to jump this last minute. Actually, this last minute, there's not even enough time to answer this one. We're going to stop right there and move on.